So I just thought I'd spend literally 2 minutes just talking about the periodic table, because you'll notice here that we'll use the periodic table, but I'm not going to use the visual of the periodic table as much. So back in the first session when we talked about exam technique, I spoke about the periodic table being one of the best resources that you can use, that and the specification, but the periodic table is given to you in your exam. So as much as the more of your revision that you can relate to the periodic table and that you can use the periodic table to remember things or to understand things or to apply things, etc., that the easier you're going to find it, because you're given the periodic table in the exam. So just a couple of things, if you weren't sure, a couple of things that you could look to connect to the periodic table is things to do with trends, obviously, in the periodic table, seeing how they fit with the periodic table, bonding and structure, because that's hugely related to the periodic table in terms of metals and non-metals, gaining, losing electrons, formation of ions. This is all to do with the periodic table. Electronegativity, you can link to the periodic table. Size, you can link to the periodic table. Our transition metals can be heavily linked to the periodic table as well. Electron structures, you can use the periodic table. There's loads, and there will be more. I've just forgotten them immediately off the top of my head. So there's loads that you can do that uses the periodic tables to help with revision. So I really, really would recommend create yourself a big poster with a periodic table in the middle and link everything to it if you can. That's what I would do, or something like that. But right, let's focus a little bit on our halogens. So hopefully we know the names. Group 1 elements, we call them alkali metals, because they become an alkali, they form an alkaline substance on addition to water, sorry. So that's why we call them alkali metals. Group 2, we don't really have a name at A level for group 2. We just call it group 2. Group 7, we call the halogens. And then group 8/0, we call the noble gases. So you can refer to them as either of those names in your exams, and they may be referred to as either as well. We do need to know what we're talking about. So group 7, that is our halogens. That is, oops, sorry, my pen's turned itself off. Let's turn it back on again. Group 7, that is these guys here. We haven't included the bottom, most recently named elements, but so that's group 7 down there on the right hand side. These are the halogens. Now I personally do try my best to be very specific with the keywords I use. I'm obviously not perfect, nobody ever is, but I do my best. So when I'm talking about a halogen, I'm talking about the neutral form of the element. If I talk about a halide, I should be talking about the ionic form. So I will try my best to be specific, and you guys should be as well, because in an exam, they will expect you to be. So halogens are group 7, lovely. So you need to know, and it says so in the specifications, you need to be able to recall the formula and state of the halogens at room temperature and pressure. Now, most of them don't call for fluorine, but we've included it anyway, because you might as well. But chlorine, bromine, and iodine, definitely you need to know the state and colour across the exam boards. So what are they? Hopefully we all know from GCSE that the halogens are part of that little kind of upside down L shape on the periodic table, which form diatomic molecules. So di meaning 2, atomic 2 atoms, 2 atom molecules. So F2, Cl2, Br2 and I2. Similar to oxygen, which is O2, nitrogen, which is N2. So that's our little upside down L shape. Again, a link to the periodic table. You don't have to remember those 1, 2, 3, 4, 5, 6 individual things, and hydrogen 7. You can remember the upside down L with hydrogen. So that's only 2 things you have to remember instead of 7. Where did I go with that? Diatomic. So they're all diatomic. Hopefully we already know they're all diatomic. Fluorine is a pale yellow gas. Okay, actually, I'm going to try and do them coloured. If you can't, you might not be able to read it. I'll do my best to. Oh no, that's going to be not very easy to read at all. Let's try a bit better. pale yellow. Fluorine is pale yellow gas. Chlorine is a pale yellow green gas. At room temperature and pressure, sorry, this is at room temperature and pressure, and you need to know these off by heart. Bromine, let's see if I can get, oh, I don't really have a brown, I've got orange. Bromine is a brown liquid at room temperature. And iodine is, and they do vary what they want you to say, but mostly they're happy with black, but do double check because sometimes they're expecting you to say a blackish purple. Or sometimes they will even accept grey, but I believe that's only at GCSE. So I think at A level we need to be saying black or blacky purple or very dark purple. But again, this is one of the things that does vary throughout the internet and across exam boards. So just double check that you're happy with what yours is expected, what is expected from you, sorry. And then let's just give them all, oops, 10. So fluorine, oh, sorry, I thought I changed that colour. Let's go back to blue. Fluorine is in the gaseous state at room temperature and pressure. Chlorine is also gaseous, but then bromine is liquid and iodine is solid. Something also to note about iodine, the other reason why sometimes they're happy with you to use the word purple is because iodine sublimates, so it goes straight from the solid state to the gaseous state without going via the liquid state. So it sublimates, and the gas that's produced, the gaseous form of iodine, is actually a lovely purple colour. It's beautiful if you've seen it. Really, really nice. But that's why sometimes they will accept purple. Or sometimes where you might see it written as purple. Okay, let's have a look at them forming compounds then. So group 7, they're group 7, which means they're over on the right-hand side. They are non-metals, or what we would class as a non-metal. And when they react, so all things react, all chemical elements react to produce compounds or molecules or whatever it is that they form, whatever they react to gain a full outer shell of electrons. That's why our noble gases, group 8, don't react, or group 0 don't react, because they've already got, or they're very inert. They do react eventually if you force them to, but they're very inert, they're very unreactive, because they've already got their full outer shell of electrons. So if they've already got a full outer shell of electrons, they don't need to react. Other elements react to gain that full outer shell of electrons, because that is their most stable configuration when they've got a full outer shell. So what do our halogens need to do to gain that full outer shell? They have to gain 1 electron, which is fairly easy to do because it's only a single electron. So single electron, it needs to be gained. Because it's fairly easy to do. By the way, easy, I mean low energy. It doesn't require much energy to gain a single electron, which means it can happen rapidly. It can happen easily because it doesn't need much energy. So this makes them highly reactive compared to lots of other elements. So it's all relative, but highly reactive compared to other elements. Halogens therefore form 1- ions, and we call negative ions anions. So they form 1- anions. Usually, we will look briefly at when there's a slight discrepancy within that description later on. But you need to be able to draw your dot and cross diagrams to show the formation of these ions. So how would you edit these atoms to become the halide ions? What would we do? Well, both are going to gain 1 electron. It's going to gain an electron next to the unpaired outer shell electron. So I'm going to do it as a cross because I'm showing that that electron has come from elsewhere. And if my fluorine atom has gained a negative charge, well then overall that species will have a 1 negative charge. It's got atoms have an equal number of protons and electrons. Protons are positive, electrons are negative. So if they've got an equal number of each, they cancel each other out. So overall, the charge is neutral. If you gain another electron, suddenly you've got a negative overall charge because you've got 1 more negative electron than you do positive proton. So it becomes an anion, negatively charged. So we're going to put in our little electron there. And same for bromine. It goes in with the unpaired electron to create a pair, and overall it will have a negative charge. So our halide ions have a 1- charge. We don't put the 1 because we're lazy, so we just put the minus. hopefully none of this is new to anybody at any point, but when they form molecules, so when our halogens exist in room temperature and pressure, they exist in molecules. And so as well as forming ions, they can also covalently bond with other elements that need one more electron, or can covalently bond to something that needs at least one more electron anyway. And they can form diatomic molecules with themselves. Atoms of halogens can form diatomic molecules with other atoms of halogens. This bond between the two, so the sharing of a pair of electrons, is what forms our covalent bond. So I'm just going to pop that in. There is a shared pair of electrons. That's not the full definition of a covalent bond. That's just a quick definition. Let's do these guys as chlorine. So that's a chlorine, that's a chlorine. They have a bond between them. These bonds, these covalent bonds, are very strong. So chlorine molecules, halogen molecules, if they are our elemental molecules, so just made up of the same atom bonded to itself, or bonded to another one of the same atom, these have very strong bonds between them. Covalent bonds are strong. So they have strong intramolecular forces. So if you are at university, you may have intramural sports or intra-house competitions, and that is within your house or within your department or whatever. So intramolecular means within molecules. So intramolecular forces mean within molecules. So these intramolecular forces or intramolecular bonds are, in this case, covalent, between our chlorine atoms. We will come to it more later, but don't forget there are also intermolecular forces between molecules. So we have intramolecular bonds within the molecules and intermolecular forces between molecules, but we'll come to that a little bit later. The intramolecular bonds are strong. Okay, let's keep going.